Okay, so get this right. We are diving into AI. Well, specifically, some new research that suggests AI might be on the brink of developing reasoning abilities.
Closer to our own system to thinking, yeah.
Exactly, that strategic problem-solving part of our minds.
Right.
Our source for this deep dive is a paper. It's called Toward System 2 Reasoning in LLMs, Learning How to Think with Meta-Chain of Thought. Quite a mouthful.
Yeah, but the paper itself is really fascinating. I mean, the fascinating thing is we aren't just talking about AI crunching numbers faster.
Right.
This is about AI learning to, approach problems strategically.
Like a human would.
Almost, yeah, like a human would.
So let's break this down a little
Yep.
bit. We've all heard of AI using like chain of thought prompting where it explains its reasoning step by step.
Yeah.
But this meta chain of thought, this Meta-CoT, is something else entirely.
Yeah, it's a whole other level. It's like the AI is analyzing its own thought process, like going a layer deeper.
Whoa.
So instead of just explaining the steps it took, it's modeling how it arrived at those steps in the first place.
Hold on. The AI is thinking about how it thinks.
Yeah. Yeah.
Okay, that's getting pretty deep. But, AI is already doing some pretty impressive things.
Mm-hmm.
Why is this Meta-CoT such a game changer?
Well, because current AI, for all its brilliance, still struggles with certain types of complex reasoning. And the paper points out that a major reason for this is the training data itself.
What do you mean? Like, is the data bad?
Not bad, but it's incomplete. So imagine, learning math from a textbook that only shows you the solutions,
Okay.
not the struggles and false starts that led to them. A lot of AI training is like that.
So the AI is missing the kind of behind-the-scenes footage of real problem solving.
Exactly.
No wonder it hits a wall sometimes.
Right, and the paper gives a good example of this with GPT-4,
Okay.
which is a very powerful LLM. It struggles with advanced math problems.
Hmm.
But it's not that it can't do the math.
Right.
It's that its training hasn't exposed it to the real process of solving those kinds of problems.
Okay, so the training data needs an upgrade. But how do we teach AI to, think more like a human expert with all the trial and error that involves?
Well, that's what the researchers are grappling with. And one idea that they're exploring is this concept of AI using search to explore different reasoning paths.
Search, like Googling its way through a problem.
Not exactly, but it does involve the AI exploring multiple potential solutions before settling on one.
Okay.
Much like, we might brainstorm different approaches. And this connects to something the researchers call the generator-verifier gap.
Okay, that sounds intriguing. What's this gap all about?
It's the idea that it might be easier for an AI to verify a correct solution than to generate it in the first place.
Ah.
Think about it. Sometimes it's easier to spot a good idea than to come up with one yourself, right?
That is definitely true for me. So
Yeah.
Are they saying we should focus on making AI like a brilliant critic rather than a great inventor?
That's one possible interpretation, yeah. Interestingly, their experiments showed that when an AI is allowed to sample multiple solutions and then a separate verifier, AI picks the best one, performance improves significantly.
So it's like a team effort, right? One AI throws out a bunch of ideas, and then a more critical AI acts as the judge, choosing the winner. That's fascinating. But are researchers seeing any evidence of this search process happening in real AI systems?
That's where it gets a little mysterious, right?
Yeah.
There are hints that some cutting-edge LLMs, like OpenAI's O1 and DeepSeek's R1, might be using some form of in-context search.
Wow. How can they tell? Is it like looking inside the AI's brain?
Not quite.
Okay.
But they can analyze the AI's reasoning traces, and they've observed things like inconsistent thought flow, backtracking, and repetition patterns that look a lot like a search process.
So instead of going neatly from A to B to C, these advanced AI systems are jumping around, trying different things, maybe even revisiting old ideas.
Exactly. But here's the catch, right? The exact training methods for these models are top secret. So while the researchers have these tantalizing clues, it's still a mystery how those models are learning to do what they do.
Okay, this is really making me think. We've talked about search and the verifier dynamic. Are there other avenues researchers are exploring to boost AI's reasoning skills?
Yeah. One exciting direction is meta-reinforcement learning, or Meta-RL. It's about teaching AI to learn how to learn.
Okay, a lot of meta talk today. Can you break down Meta-RL for us.
Sure. So imagine, instead of just teaching a student to solve one type of math problem, you teach them how to learn any type of math problem.
Okay.
That's the power of Meta-RL. It's about creating AI systems that can adapt to new problem-solving situations, not just master a specific set of tasks.
So instead of giving the AI step-by-step instructions for every situation, we're giving it the tools to figure things out on its own.
Exactly. And here's where the link to Meta-CoT comes in. Researchers believe that Meta-RL could be used to train LLMs to refine their in-context search strategies, making them even more efficient and capable.
So the AI isn't just searching for solutions, it's searching for better ways to search. Man, we're going deep down the rabbit hole here. But can Meta-RL really lead to AI that outperforms human-designed algorithms?
That's the big question. And it's still up for debate. Early results are promising, but there's much more to explore.
All right, so lots of potential, but plenty of unknowns as well. What are some of the biggest roadblocks researchers are facing in this quest for advanced AI reasoning?
Well, one major challenge is ensuring the accuracy and reliability of the reasoning chains that LLMs generate. It's not enough for the AI to get the right answer. Its reasoning has to be sound, logical, free of errors.
So it can't just be right, it has to be right for the right reason.
Exactly.
Makes sense.
And that ties into the need for better data sets.
Okay.
To train LLMs for advanced reasoning, we need data sets that go beyond just solutions and actually show the entire thought process. The steps, the decisions, even the mistakes a human expert might make along the way.
That sounds like a massive undertaking. Gathering all that detailed data would be incredibly time-consuming.
It would, but the payoff could be huge. Imagine AI that not only solves complex problems, but can explain its reasoning in a way that we humans can understand and trust.
Yeah,
That would change everything.
it would indeed. So what does all this research mean for the average person? Why should we care about AI learning to reason more like us?
I mean, this research is still in its early stages, but its potential is enormous. We're talking about AI systems that could be more creative, adaptable, and capable of tackling real-world problems that require more than just following instructions.
So a future where AI is more like a partner in problem solving than just a tool.
Exactly.
That's a pretty big deal.
It is. And if LLMs can learn to reason strategically, it begs the question, could they eventually discover problem-solving approaches that we haven't even thought of?
That's a mind-blowing possibility. We've covered a lot of ground already, but I'm still curious to learn more about how researchers are teaching AI to think about thinking.
Well, one approach they're using is called process supervision,
Okay.
where they provide feedback not just on the AI's final answer, but on each step of its reasoning process.
So instead of just grading the final exam, it's like giving feedback on every single step of the student's work.
That's a great analogy. And that's where process reward models, or PRMs, come in.
Okay, this sounds like a whole other layer of complexity. What exactly are PRMs and how do they fit into all of this?
Essentially, PRMs are AI systems designed to, judge the quality of the reasoning process itself. They can tell whether the AI is making logical jumps, following a coherent line of thought, and avoiding common pitfalls.
It's like having an AI teacher guiding the AI student towards more effective reasoning. Pretty clever.
Yeah.
But I imagine training these PRMs isn't a walk in the park.
You're right. One of the toughest challenges is figuring out where to get the training data for these PRMs.
Yeah.
Ideally, we'd have human experts meticulously annotating tons of problem-solving examples, highlighting the good and bad reasoning steps along the way.
Right.
But that's incredibly time-consuming and expensive.
So researchers are in a bind. They need these PRMs to train AI for advanced reasoning. But training the PRMs themselves requires a ton of human effort.
It's a classic catch-22. But thankfully, researchers are exploring some creative solutions.
Right, I'm all ears. What kind of solutions are they coming up with?
One approach is to let the AI help itself. So instead of relying solely on human input, they're trying to train PRMs by having them watch other AI systems solve problems, learning from their successes and failures.
So it's like a form of AI peer-to-peer learning. That's brilliant. But how can they be sure that the teacher AI is actually good at reasoning in the first place?
That's a great question. And this is where outcome verification comes in.
Okay.
They start by training a basic AI system to solve problems and get feedback on whether its final answer is right or wrong.
So it's a first draft where the AI is just trying to get the right answers, even if its reasoning is a little messy.
Exactly. Then they use this basic AI with its known outcomes to train the PRM.
Wait, so the PRM is learning to evaluate reasoning by watching an AI that may not even be reasoning all that well.
It sounds counterintuitive, but it's a way to bootstrap the process. The PRM learns to identify patterns in the basic AI's reasoning that are linked to correct or incorrect results.
So the PRM is picking up on subtle cues that even humans might miss. Amazing.
Right. And as the PRM improves its ability to judge reasoning, it can then be used to train more sophisticated AI systems that can reason even more effectively.
It's a virtuous cycle, with the AI helping to improve its own reasoning abilities over time. Incredible. But I have to admit, this is all a bit overwhelming. Are there any key takeaways that would be particularly helpful for our listeners to grasp?
Absolutely. I think the most important thing to remember is that this research is all about teaching AI to think about thinking. It's not just about making AI faster or more efficient, but about creating systems that can reason strategically, learn from their mistakes, and potentially even surpass human abilities in some areas.
That's a powerful concept, and this research could impact our lives in profound ways.
Without a doubt, there are still challenges to overcome. But the progress being made in AI reasoning is truly remarkable. We're witnessing the birth of a new era of intelligent systems, systems that could transform our world. So, before the break, we were talking about some of the hurdles researchers are facing in training those PRMs, those AI teachers, that evaluate reasoning. One really interesting approach they're exploring is using synthetic data.
Synthetic data. So instead of relying on, real-world examples of problem solving, they're creating artificial data sets. Why go that route?
Well, it's kind of like, building a custom training ground for the PRMs. With synthetic data, they can expose those PRMs to a much wider and more challenging range of reasoning patterns than they'd find in the real world.
Okay, so instead of just feeding the PRM, right or wrong answers, they're showing it all the different ways an AI might arrive at those answers.
Exactly.
Even the, messy or incorrect ones, I get the idea. But how do they actually create these synthetic data sets? It sounds incredibly complex.
It is complex. One technique they're using is to simulate different search processes. Remember how we discussed, AI potentially using search to explore different reasoning pathways?
Yeah.
Well, researchers are generating synthetic data that mirrors those search patterns, including all the backtracking, branching, and exploration involved.
So they're using algorithms to simulate how an AI might fumble its way through a problem and then using those simulations to train the PRM. That's pretty meta.
Exactly. And to do this, they're using algorithms like Monte Carlo tree search or MCTS.
Yeah.
It's a technique that's often used in game playing AI, where the AI simulates tons of possible moves and outcomes to figure out the best course of action.
This whole process is starting to feel a bit like AI inception, right? We're using AI to create data, to train AI, to judge the reasoning of other AI. It's mind-boggling, but also pretty awesome.
It is pretty wild. But it shows the incredible ingenuity of these researchers, right? They're constantly pushing the boundaries and coming up with these creative solutions to train AI for advanced reasoning.
Speaking of pushing boundaries, earlier we talked about how crucial it is to ensure the accuracy and reliability of AI's reasoning. Are researchers finding ways to make sure that, those AI thought processes are really sound and trustworthy?
Yeah, that's a tough nut to crack, and there's no magic bullet. But one promising approach is to bring humans back into the loop. So instead of just relying on automated metrics, they're getting human experts to evaluate the quality and coherence of the AI's reasoning.
So it's like having a human editor review the AI's work, providing feedback and guidance.
That's a great way to think about it, yeah. And this human feedback helps fine-tune the AI's reasoning abilities. Of course, getting, high-quality human feedback on a large scale is a challenge. It's time-consuming and can be expensive.
So how do they, overcome that?
Well, researchers are working on some clever techniques like, using crowdsourcing platforms or developing AI systems that can pre-screen the AI's output and flag any, potential issues for a human to review.
So it's a mix of human intelligence and AI efficiency. I like it. It sounds like ensuring transparency and explainability in AI are becoming key priorities.
Absolutely, especially as AI systems are, being used in more and more sensitive areas like healthcare, finance, and even criminal justice.
Right.
If we're going to entrust AI with, making important decisions, we need to be able to understand how it's arriving at those decisions.
Makes sense. And it highlights why this research on advanced AI reasoning is so important, right? It's not just about building smarter machines. It's about building machines that we can understand, trust, and collaborate with. So apart from these approaches, are there any other interesting findings from the paper that you think our listeners should know about?
Yeah, there is one finding that's particularly intriguing. It seems that the way AI systems reason might actually be converging with how humans reason.
Really?
The researchers who analyzed those advanced LLMs, like OpenAI's O1 and DeepSeek's R1, they found patterns that closely resemble human cognitive processes.
Wait, so even though these AI systems are trained using like completely different methods than how humans learn, they're ending up with like similar reasoning styles.
Yeah, it's a pretty remarkable discovery. It suggests that there might be some fundamental principles of reasoning that apply across both, biological and artificial intelligence. Now, there's still a lot we don't know.
What are some of the like the big unanswered questions?
Well, for one, we don't yet know if these similarities in reasoning are just, superficial, or if they reflect a deeper convergence in the underlying cognitive mechanisms. Are these AI systems actually thinking like humans, or are they just mimicking human thought patterns in a way that, happens to be effective for solving problems?
That's a pretty deep philosophical question.
It is. And another open question is whether these advanced reasoning abilities will eventually emerge in AI systems trained using, more traditional methods like supervised learning, or if they will always require more specialized techniques like meta learning or reinforcement learning.
So it's possible that the AI of the future might not need all this scaffolding of PRMs, synthetic data, and human feedback to learn how to reason effectively. It could just figure it out on its own.
Yeah, it's certainly a possibility. And if that turns out to be the case, it would have a huge impact on how we develop and deploy AI systems, making them more accessible and less resource intensive.
That would be a game changer. But even if those advanced reasoning skills still require those specialized training techniques, the research being done now is paving the way for a future where AI can truly reason more like us. And that's incredibly exciting.
It really is.
So we've covered a lot of ground here. Before we move on, is there anything else you want to add about the potential impact of this research?
I think it's important to remember that the development of advanced AI reasoning has the potential to impact, nearly every part of our lives. These systems could help us solve complex problems in healthcare, climate change, education, scientific discovery, and so much more.
So it's not just about AI that can beat us at games, right? It's about AI that can partner with us to tackle humanity's biggest challenges.
Absolutely. And if we aim to develop these AI systems to reason effectively, ethically, and transparently, it could lead to a new era of progress and prosperity.
That's an optimistic thought, but I know some people might be feeling like anxious about AI becoming more human-like in its reasoning. What would you say to those who are feeling, uneasy about this research?
It's understandable to be concerned about the implications of, advanced AI, especially when talking about systems that might surpass human abilities. But it's important to remember that AI is a tool. Like any tool, it can be used for good or bad. What matters most is that we develop and deploy AI responsibly, taking, ethical implications and societal impacts into account.
So it's not about fearing the technology itself, but about being thoughtful and intentional about how we use it.
Exactly. And I believe that the research on advanced AI reasoning is moving us in the right direction. By developing AI that can reason transparently and ethically, we're increasing the chances that these systems will be used for good and that everyone will benefit.
That's a reassuring message. And it's important to remember that this research is still in its early stages. We're a long way from AI that can truly match or exceed human reasoning.
That's true, but the progress being made is incredible. We're on the cusp of a new era in AI. It's important to approach this with a blend of excitement and caution, prioritizing ethical considerations and working towards AI systems that enhance human capabilities, not replace or diminish them.
Well said. That's a great note to end on. We've covered a lot in this deep dive, and I, for one, am both excited and humbled by the potential of this research. But for now, let's take a short break. When we come back, we'll shift gears and look at some real-world examples of how these advanced reasoning techniques are being used in action. Stay with us. Welcome back to the deep dive. We've spent the last two segments exploring, the cutting edge of AI reasoning, and now it's time to see how all this mind-blowing research is actually being applied, like, in the real world.
Yeah, what's really exciting is that we're seeing these, advanced reasoning techniques popping up in like all sorts of fields, from, scientific breakthroughs to creative problem solving and even tackling some of society's biggest challenges.
Okay, let's get specific. Where are these thinking AI systems actually making a difference? Give us some real-world examples.
Sure. One area where we're seeing like major progress is drug discovery. Think about it. Traditionally, developing new drugs has been a slow, painstaking process of trial and error. But now researchers are using AI that can reason about complex biological processes to pinpoint promising drug candidates.
So instead of blindly testing like thousands of compounds, these AI systems are helping researchers zoom in on the most likely contenders. That sounds like a huge time saver.
Oh, it is. These AI systems can analyze mountains of data, spot patterns human researchers might miss, and even suggest entirely new molecular structures that could have, therapeutic potential. It's like having a super-powered research assistant working around the clock.
That's incredible. So we're talking about like potentially finding cures for diseases that have plagued us for centuries. What other fields are benefiting from this kind of AI ingenuity?
Another area where things are really heating up is material science. Researchers are using AI to design new materials with specific properties, things like strength, conductivity, or heat resistance. These AI systems can analyze the atomic structure of a material, predict how it'll behave under different conditions, and even propose new combinations of elements that could create materials with, unheard of capabilities.
So we're talking about the potential for materials that are like lighter, stronger, more durable, maybe even self-healing. That sounds like something straight out of science fiction.
It does, doesn't it? But it's becoming reality, and the potential applications are vast. Think aerospace, electronics, construction. This could revolutionize the way we build and create things.
It sounds like this technology has the power to completely reshape the world around us. But we've been focusing a lot on the scientific and technological applications. Are there any examples of AI reasoning being used to tackle social or environmental problems?
Absolutely. Climate change is a huge one. Researchers are developing AI systems that can, crunch through massive amounts of data from climate models to identify the most effective strategies for reducing greenhouse gas emissions. They can even help optimize energy grids, making them more efficient and sustainable.
So these AI systems are acting like superpowered advisors, helping us make smarter decisions about how to combat climate change. That's a real game changer.
It is. We're talking about potentially making a significant dent in our carbon footprint, transitioning to cleaner energy sources, and ultimately leaving a healthier planet for future generations.
These are some truly inspiring examples. But before we get carried away by all the positive potential, I want to bring up the ethical considerations we touched on earlier. How are researchers making sure these thinking AI systems are being developed and used responsibly?
Yeah, that's a crucial question, and one that researchers are taking very seriously. A big focus is on making sure that these AI systems are aligned with human values. That means not just teaching them to follow rules, but actually instilling a sense of, ethical principles and social norms.
So it's not just about programming the what, but also the why. That makes sense.
Right. And there are lots of, different approaches being explored to achieve this. Some involve incorporating ethical considerations directly into the training data, while others focus on developing new algorithms that explicitly factor in human values. It's a multifaceted challenge, but it's one that researchers are committed to addressing.
It's reassuring to hear that there's this, awareness of the ethical dimension. As AI continues to evolve, we need to keep having these conversations and make sure these systems are serving humanity in a positive way.
Absolutely. It's an ongoing process. We need to be vigilant and, constantly reevaluate the ethical implications as AI reasoning capabilities advance. This is uncharted territory, and it's important that we proceed with both enthusiasm and caution.
This has been an amazing deep dive. I'm honestly a little blown away by the potential of this research. Before we sign off, any final thoughts for our listener?
Yeah, I think the key takeaway is that, we're seeing a fundamental shift in AI. We're moving beyond systems that just process information to systems that can reason, learn, and maybe even think in ways that are startlingly similar to how humans think. This is an incredibly exciting journey, but it comes with a huge responsibility. It's up to us to make sure that AI reasoning is used for good and that we build a future where humans and AI can work together to solve our biggest challenges and create a better world for everyone.
That's a powerful message. And on that note, I want to thank you, our expert guest, for taking us on this incredible journey. And to our listeners, thank you for joining us for this deep dive. We'll be back soon to explore more cutting-edge science and technology. Until then, keep those minds curious.